This is a presentation that I was honored to give this group in 2017, and I'm very pleased to be invited back on this 100th anniversary of this historic station. A little bit of background. When John Fasella contacted me about doing this presentation or doing a presentation in 2017, he said the symposium was going to be in Pittsburgh, and it was, as part of the program, was going to be a tour of KDKA. And I said, well, I'd worked on the tower project there in the mid 90s, and he graciously took me up on the opportunity to talk about that project. As a young engineer, I went to work for Moffitt Larson and Johnson consulting engineering firm here in Northern Virginia. And I went to work for a guy named Jeff Bixby, or Bix as he liked to be called. And Bix was in the middle of this KDKA tower project when I started with the company. Bix was a Radio Club of America member. He was very proud of his membership in this organization, and he also took the opportunity to attend most of the awards banquets in New York. Unfortunately, Bix passed away in 2005, and I couldn't pass up an opportunity to give this presentation to a group that was special to him and about one of his most favorite projects. So this is an opportunity to talk about other people's work. This is largely based on a paper that Bix gave at the 1995 National Association of Broadcasters Convention in Las Vegas. And it gave me the opportunity to go through several large file folders of notes and pictures and mini neck printouts that I've had in my basement since he passed away. It'll cover the original tower, electrical design, and the design and construction of the current tower that was erected in 1994. So as I understand it, the old KDKA tower was built for the first time in 1938 in Saxonburg, which was some 25 miles from the center of Pittsburgh. They completed the tower construction, and it was accompanied by a wave of promotion and publicity. But when it was actually turned on, it didn't work so well. It was too far from the center of town, and in addition, it had a high angle of radiation, vertical radiation, that came back down and interfered with itself in its ground wave service area. So we called that self-fading or self-interference. And it couldn't be heard in Pittsburgh at night. So several years later, the tower was disassembled and moved and re-erected at the present site in Allison Park, Pennsylvania, which is about 11 miles from the center of town. And until 1994, KDKA operated from that site with that tower. But the suburban population continued to expand out into the suburban area, and the self-fading eventually became a problem because it was now, again, interfering within its desired coverage area. So the original KDKA tower was a 3/4 wavelength dipole, commonly referred to as a Franklin antenna, sectionalized or insulated in the middle and then also insulated at the base. And of course, in AM radio, the tower is the antenna, since wavelengths are on the order of 1,000 feet or so. And the vertical dipole, as I said, it's insulated at the bottom, fed in the center by a balanced transmission line. Here's a schematic of the transmission system. You can see the transmitter comes here from the coax comes here from the transmitter, this balun right here, and then the tower is fed by balanced transmission lines going up the center of the tower, with one connected to the top section, one connected to the bottom section. Here is a bigger picture of that balun. And since it's insulated at the ground, and the base feed apparatus is also a load across the base insulator between the base of the tower and ground, every time that base tuning apparatus was changed or modified or replaced or reconfigured, the load across the base insulator changed, and that caused a change in the current distribution between the upper and lower sections, or the relative current distribution between the upper and lower sections, and which also, as you would expect, caused a change in the vertical radiation pattern of the antenna. Some were more favorable than others with respect to their self-interference or self-fading, but none was really ideal. So since the base loading function was incidental to the tuning and the impedance matching, then no effective vertical pattern control was was feasible. Here's another picture. This is I should say this was the balun at the base of the tower that was moved inside the transmitter building before the tower was disassembled. And then here is a picture of a guy wire insulator. So in the early 90s, the 1938 tower was not in good structural condition and needed to be replaced. So the question is, well, what do we replace it with? And the station went through a number of iterations of trying to figure out what to do. Do we replace it with the same thing? Well, that kind of didn't work. We can put a half wave tower up there. We could do a 5/8 wave tower. They're pretty efficient. Or we could try and modify this Franklin. Considerations, they wanted to, of course, maximize their daytime and nighttime coverage and improve this self-fading problem that had plagued them for many years. And as every broadcaster wants to do, minimize cost. So the options, we can rebuild the existing Franklin. It was a whole lot more expensive than just a simple vertical tower, but it had good efficiency and still got this problem with self-fading and interference. And the long-term operation is definitely more complex than a regular tower. Do a simple AM tower. Let's just do a simple half wave. Well, that's fine. That's probably the least expensive of all the options. It doesn't have the problem with self-fading or interference. However, it's not as efficient as the old tower or something we could do newer. It's about a dB less efficient, which was roughly about equivalent of 39 kilowatts with the old tower. Well, you could do 5/8 wave. As you know, with the 5/8 wave antenna, it has a significant, it's efficient in the ground wave, but it has a significant high angle vertical lobe. And that would make the self-fading and the interference even worse. And then finally, this modified Franklin, as we're calling it, it was more expensive than a regular AM tower, more complex to operate, but the ground wave performance was as good, if not better, than the current antenna, and definitely the self-fading was much better than the 5/8 wave, and we could control it. And that was the most advantageous. So here is a comparison of the two antennas, or the two towers. The old Franklin, they're both the same height. The modified Franklin is a half wave over a quarter wave, still fed in the middle. So how do we go about doing this? Well, the first step is to remove the old tower. So there's a picture of it coming down. It was pulled over by another guy wire that was put on it, and then it broke in the middle with those middle insulators and then fell. So what does a station do with a 60-year-old tower steel? Well, you sell pieces for a fundraiser. So they chopped up the 1-inch solid legs and raised money for Children's Hospital. And this is a picture of one of those things encased in acrylic. Here's the new tower. It was specifically designed to retain the excellent ground wave performance of the older Franklin while dramatically reducing that high angle radiation to eliminate or at least reduce the self-fading. Here's a picture of the current distribution on both of the towers. This is as best we could predict with the old Franklin. We're not really sure how it was tuned and how it was designed, and there was no real effort made to measure it because it was going to be replaced. Current distribution, or rather phase on the new tower. And then this is really what we're talking about, is the magnitude of that high angle lobe. The modified Franklin, to be practical, met the following design criteria. Ground wave performance was essentially the same as the old Franklin. The high angle radiation in the 60 to 80 degree range was substantially lower than the old Franklin to minimize the self-fading. And you can see it's in the order of 15 to 20 dB, if not more there. And the height had to be the same, or it couldn't be any taller than the old tower because we didn't want any local zoning or FAA problems. We needed a simplified feed apparatus, and we needed to isolate the functions of impedance matching and base loading so that one could be adjusted independently of the other. A few pictures of the construction. There's those center insulators. There's setting the base tower on the base insulator. And then this is one of the insulators that insulated conduit going up the tower. From the tower, we'll talk about that in a little bit. And the base of the new tower with everything connected. The antenna was fed at the sectionalized insulator in the top by a coax cable, eliminating the need for a balun and balanced feed line going up the middle of the tower. Since the impedance matching network is also located up at the at a box up on the tower, adjustments to it do not change the load at the base, thereby isolating the impedance matching and the base loading functions. There's the whole tower. You can see the work platform, and then in the tuning unit is mounted up there a third of the way up the tower. And then here's that base tuning unit. So the base loading was accomplished by a parallel resonant tank circuit within this box between the base and the tower ground. So there's a bowl insulator on the other side of this, and then ground here. And then none of this was connected to that. That's all isolated from this base loading circuit. And the impedance of that circuit could be adjusted over a wide range to provide the desired current distribution. Both the center tuning unit and the base loading assembly were equipped with motor-driven components, so complete adjustment could be established by remote control from the transmitter building. Since the tower is insulated at the base and at 270 feet above ground, it was necessary to provide a means of isolating tower lighting and a sample line across both sets of insulators and all lines across the base insulator. Since the transmission line was to be 3-inch heliax, it was impractical to wind a length of heliax, 3-inch heliax, into an isolation coil. So they decided to the transmission line would be installed as a quarter wave or bazooka section across the base insulator. And the line would be insulated from the tower from the ground level to a point about 90 degrees above the base insulator, where it was then bonded to the tower. And from there, it would remain in the tower potential to the sectionalizing insulator. And that forms the quarter wavelength stub across the base. And the base, the transmission line could then be grounded at the base. So in the final configuration, the lighting conduit was fabricated of 3-inch thick-walled galvanized steel. It runs down the center of the tower from the top plate to near the base in a straight line, and then supported with insulated hangers in the bazooka section portion of the tower. And we saw those, and you could see that insulated hanger right there. And the tower lighting and control wires were run within the conduit, and then the conduit also served as a support for the 3-inch heliax transmission lines, which you see here. 2 of those going all the way up the tower. That was a main and a backup. I figured and those went all the way back into the transmission, the transmitter building. I figure you're putting it in, you might as well put in a backup. It doesn't cost that much more. And you've got it in case you need it. So, and then about 10 feet above the base of the tower, the conduit and the lines exit the tower, make a smooth, large radius curve down toward the ground, as you can see in the picture. So it accomplishes a number of things here. where advantage is the entire tower is now at DC ground with a large diameter in that conduit, robust conductor for lightning protection. It also isolates all the lines and the cables across both sets of the insulators without the need for ring transformers or chokes. And it provides support for the transmission line. So here's a picture of BIX at the base. And the new tower was built by Stainless and made the Stainless 1995 September calendar. Here you can see the center insulators, work platform, and tuning unit with those motorized components. Only non-directional station I'm aware of that has an antenna monitor. It's a bad picture of it, but and then the controls for those tuning components. There were 2 sample loops on the tower, one in the upper section and one in the lower section, to provide real-time monitoring of the ratio and phase, current ratio and phase of the 2 sections. There's a picture of a younger version of me. I was really there. And Bix had a tradition of saying the first station ID on every station that he worked on, or every new station that he worked on. So that's the first ID on the new tower from a studio they had there at the transmitter building. And this is Bix and Charlie Fagan, who was the engineering manager at KDKA at the time. And it's standing in front of the last Westinghouse 50 kilowatt transmitter that they used there. So how did it work? Well, actually worked very well. The destructive self-fading or self-interference, it's difficult to measure. It varies with time of day and with season and sunspot cycle and so on. But to our knowledge, there were no quantifiable measurements taken on the old antenna, so we didn't have any direct comparison. But however, anecdotal evidence based on listener supports and spot listening tests by the KDKA engineering staff universally agreed that the self-fading in the areas of concern was gone. In other words, the coverage was better where they had problems before. So that's a good thing. And since then, had a few problems to sort out. One was we found the circulating currents in that upper tuning cabinet burned off the latches in the cabinet, since that was the only conduction between the cabinet doors. So I ended up replacing the door with a Lexan door. And then there was this one intermittent problem with some arcing somewhere on the tower that we could never locate. It was the only problem with it was that it would cause a solid state transmitter to take a VISWAR hit and briefly mute, which was kind of annoying to the listeners, and it was annoying to the management. And it only happened on the DX50. The MW50 tube type transmitter would power through it, but it did happen on the DX, which was their new transmitter. And it seemed to happen more often when there was a storm coming. So I did a number of things. They installed static drain chokes on the guy wire insulators, changed out several components to try and fix this arcing, but no silver bullet was ever found. And it really nagged Bix for the rest of his life. The project that was 99% a success, and he still had this one lingering problem. 6 or 8 years ago, another engineer, Don Crane, was hired to work on the problem, and there had been several other engineers in and out of there, and I'm pretty sure Ron Rackley worked on it. And Don happened to notice that the insulators that were on this bazooka section were spec'd in the spec for 50 kV, but the ones that were actually installed were 30 kV. And went through the original mini neck models, and it clearly showed they needed to be 50 kV insulators, and so they replaced these insulators. This is the old one, but and that actually fixed the problem, and fixed that arcing problem. And Don tracked me down like soon after that to tell me, and he knew Bix had passed away, and unfortunately didn't get to see this problem solved. But Don did track me down to tell me that, which was nice of him. Since then, and these pictures coming up came from Chris Hudak. They've had other issues on the tower. The tower sections, 20-foot tower sections, were supposed to be tack welded together, but they were apparently not. Something you can't see from the ground. You have to trust that your tower crew did the right thing. And this caused uneven currents to flow in the legs, which then caused high voltages across bolted tower section cross members. And you can see the tower arcing obviously on this bolt. There's another hole, bolt hole with arcing, and then this one was particularly bad. And then also the galvanized conduit tower section, or galvanized sections, developed rust across the couplers, which caused heating and or arcing, and burned the insulation off the transmission line. You can see, or I'm sorry, not transmission line, but sample line. So, like I said, lessons learned is trust but verify, and make sure everything is electrically connected, and that the insulators are the correct rating. So that pretty much concludes my talk. Special thanks again to Bix, who I get to talk about his work today, and whose name got left off these slides in 2017. Also to Chris Hudak and Jim Gracie for providing the more recent pictures and spending several hours on the phone with me talking about the station and graciously letting me do this presentation about their station. And to Don Crane for finding and fixing that one nagging problem. And thanks to my current employer, Cavell Mertz, for letting me present this 2 different times and letting me come reminisce about a 20-year-old project that they had nothing to do with. And thank you again for letting me make this presentation. Congratulations to KDKA on a significant milestone in broadcasting history.
Thank you, Mike. Great presentation, just super. And we encourage the participants online here to put questions in the chat or in the Q&A for our moderators to pick up. And thanks to our moderators, John Doerr and Scott Jones. And Mike, that I could sit through this presentation 5 or 6 times. I love everything about it. It just is super. And I thank you so much for coming on today and doing that. And wanted to make sure that everybody that is on the Zoom call here for the 2020 Technical Symposium, that if you're not a member of the Radio Club of America, please consider joining. And if you go to our website, radioclubofamerica.org, we have a special, and you can join for 3 years for a very special low price of $150. So if you're not a member, consider signing up and becoming a part of the world's oldest wireless club, the Radio Club of America. So with that, John, let's start with you and questions for Mike Rhodes.
Sure. I would just echo Tim's comments. I think those of us who are amateur radio operators, when we see what happens with adult towers, it's just a completely different world, isn't it? One of the old adages, Mike, is they never build things today the way they used to. That applies to appliances and cars and all kinds of things, right? compare the two towers, does that adage apply to the KDKA towers version 1 and 2, or was version 2 a significant enhancement in terms of quality and all of that, mechanically speaking?
Well, you're talking to an electrical engineer, so mechanically speaking, I think it is. Of course, that the old one lasted for 60 years, so we'll see if that turns out to be true. This new one, from an electrical standpoint, was certainly much more controllable, much more serviceable than the old one. But then I'll defer to Chris, and he's the one that's maintaining it, and he'll tell you more about it coming up next. So
fair enough.
And Scott, a question for Mike.
Sure. How did the KDKA programming continue during the teardown and construction of the new tower?
Good question. So
was there a secondary site? If so, what was the power and the location and that kind of thing?
They have, if you look their site up on the map, they have a quite a large land area out there, and they actually have a quarter wave auxiliary tower on the property, not far away from the transmitter building. And so they were able to operate for the most part continuously on that auxiliary tower while they tore down and rebuilt the other tower. I think there were some times in there that cranes and cables and so forth got a little dicey, and they needed to power down or turn off. But for the most part, they operated continuously on that aux tower.
So if you have questions, please put them into the chat or the Q&A area, and our moderators will pick them up. And John, another question for Mike.
Sure. Mike, in our area here in the Boston metropolitan area, our marquee station at WBZ, and it's
another Group W station, former Group W station.
Correct. It's pretty widely known that WBZ gets lots of reports. I think they've received reports from all 50 states and overseas as well. I'm curious if you're aware of any Skywave stories or the kinds of reporting that KDKA receives in a similar way.
I am not. I know they do have people, as a lot of AM stations do, have listeners that will report in. That's a question you might save for Chris or Jim, and I'm sure they're still getting those. So
yes, in fact, Tuesday night we had one of our RCA roundtables on an interview series, and we had Jim Gracie on, and Jim did confirm that they're still sending out QSL cards. So,
good.
Time honored tradition there. Scott, another question for Mike.
Back during the initial construction, the planning for the new tower, what kind of challenges were presented with building this size of a structure? What kind of zoning or environmental or FAA or any kind of other permitting process issues might there have been?
As far as challenges, I think that was one of the design criteria was to minimize those, and so one of the criteria was we can't go any taller. We don't want to go through zoning and that kind of thing. We're just replacing the tower that's there. And in fact, they were 100 feet, couple hundred feet apart from the old tower. So that was one of the criteria there was don't create any problems.
So Mike, tell us about the ground system. What is the requirements for optimum performance of the modified Franklin from a ground system perspective?
From a ground system perspective, I think it's there was no changes made to the ground system. I don't believe we put in a new ground system at the time. We tied into the old existing ground system there.
Do you know what that was?
I do not. I think the FCC required 120 radials going out, about a quarter wave. So I'm not exactly sure what the ground system was, but I'm pretty sure we did not put in a new ground system there. I don't
Okay.
recall.
Yeah,
We did have, in some of the pictures you can see there is a ground screen at the bottom. So there was a expanded copper mesh ground screen that went out about 20 feet all around the tower, inside that fence.
Okay.
So
All right. Maybe Chris knows when he gives
might.
his talk. John, another question for Mike.
Sure. There's two here that are sort of related that I'd like to tie together, and they have to do kind of with maintenance and operation of the tower itself. So part A is really what kinds of ongoing structural maintenance, scheduled maintenance is necessary for a massive structure like this. And related to that is when it is in operation, particularly given and being in the Pittsburgh area where snow and ice is a common event, starting around this time of year through the spring. Are there any special mitigations or things that can be done to help deal with that?
I get, your regular tower maintenance and tower inspections and inspecting guy wires and, of course, painting. I don't know. I'd have to ask Chris how many times they've painted it in the last 20 years, but probably a number. And snow and ice, I don't think typically affects these. Those insulators on that thing are pretty far apart, so they're not going to get any snow and ice across those insulators. And so I would say that there's probably not any issues with that. Obviously, there's structural considerations that went into the design of the tower for ice and ice loading and wind loading and that kind of thing. I don't think anything special for this one compared to any other tower. So.
And Scott, another question for Mike.
All right. There's been a couple of people that have been curious about the design of the foundation, the concrete base for the tower, how big it is, how far underground it is, that kind of stuff.
I do not remember. Sorry. It was, I don't know if I can find a picture real fast of it. That one's not bad. But as far as how far down it went, I do not remember. I'm sure I have it in some file folders in the basement.
Okay. It is a nice looking foundation. John, another question for Mike.
Yeah, just a side comment. Somebody here indicated that they were a KDKA listener in 1948.
Oh, wow. That's great.
So long-time listener, first-time caller, I guess.
There you go.
Applies in that category.
Fantastic.
In the process of the new tower, of course, in today's world, environmentals are front and center of getting out of bed in the morning, much less putting a tower up. But what did you have to deal with environmentally and dealing with the area and local government authorities and all that at the time you put the tower up a second?
In this one, I don't recall any specific problems. At the same time, we were also doing 1010 Winds site in the Meadowlands in New York, and I can tell you that was infinitely more issues in building those towers in the Meadowlands than this tower in Pittsburgh. So I don't, like I said, we were essentially replacing a tower that was already there, and so I don't recall any. And certainly in the 90s, the environmental with birds and that kind of thing was not near the problem that it is today. So I don't recall any specific problems that we had, either zoning wise or environmental wise. And like I said, it was much much less than what we dealt with at Winds, where we were counting grasses and that kind of thing in the disturbance in the Meadowlands.
Mike, what kind of work are you doing now in the world of engineering?
I'm still doing primarily broadcast consulting engineering. The firm does all sorts of wireless, microwave, that kind of thing. I'm right now on the TV repack project, working with the FCC, reviewing invoices and for the TV repack, where all the TV stations repack down to channels 2 through 36, and the FCC, as part of the auction, pays for the TV stations changing out antennas, transmitters, towers, whatever was needed. And so we're working with the fund administrator on that project. So I've been busy with that for the last couple of years, and that'll continue for the next couple of years. But you know, AM, FM, TV type engineering. We have other people in the firm doing a fair amount of AM work these days.
That's great. That's great. AM is far from going extinct.
It is. We do have a lot of people that are selling their property and going non-directional from directional, just to stay on the air when they find they're in the real estate business, not in the broadcasting business.
Scott, another question for Mike.
All right, we just had a question came in. They were intrigued by the fact that the tower wasn't tack welded as specified.
So were we.
And they wondered if it was done some at the bottom and it just stopped at some point going up the tower, or
I don't know. In the first sections, 20 feet tall, it's kind of hard to see up the first section, and it wasn't something that we specifically checked. So I'm sure it was in the spec. I don't know why it wasn't done, or if it was done part way and not all the way. I don't know. And we weren't on site. We'd made frequent trips up there, but so.
Okay, John, another question for Mike.
Sure. Hey, we finally got an RF electrical question for you, Mike. Not what color the bolts are. So here, somebody is suggesting that a typical 120 radial quarter wave system, such as what you described, is not necessarily necessary for this type antenna being a vertical dipole. Maybe you could comment on that, and then if that's indeed the case, in your opinion, why would you have such a ground system, for example, to use the ground screen for RF ground or some other application? Any comments on that?
I didn't study it, with and without a ground system. I would say that there's reality and there's engineering, and then there's FCC policy. And so this one, of course, you want a stable ground at the bottom, and that's why this ground screen. You can see the ground screen there in that picture that I shared, that I'm not sharing anymore. And you can see the bases, and this is bonded to this ground screen here. And then of course the tower and the base was connected to ground through this tuning unit. So it's not a vertical dipole in the sense. It's actually a quarter wave antenna above ground, and within the half wave on top of that. So I'd say the ground is important, very important. And as far as what the minimum number of ground radials are, that's a whole other topic of discussion. But in the FCC world, they want to see 120 radials, and so that's what we've generally put in.
Brown, Lewis, and Epstein.
Exactly right.
Those famous guys.
Been debated many years.
Yes, I mean, and somebody perpetrated a rumor they just ran out of wire.
Yeah, exactly right, because that's how much wire they had. Yeah,
that's right. Mm-hmm. Scott, another question for Mike.
Sure. Do you know what the decision process was back in the early days not to have a directional antenna, instead going with an omni, if you will? Some other stations like WOR had some directional capabilities, and KDKA didn't. I was just curious what that might be from.
I mean, KDKA was one of the originals. There's a number of reasons for having a directional antenna. One is to avoid interference, and some of the and then as more and more non-directional stations filled up the band, then they needed to have the directional stations to avoid interference. There were stations that were originally directional to avoid wasting coverage. I know there's some of the first ones were put in Florida. WBZ you mentioned, John, I think was directionalized to do some of that, and also to avoid its first adjacent sister station, KDKA. So, oh no, sorry, I'm sorry, that's KYW in Philadelphia.
KYW, yeah.
Yeah.
So let's see here. We got time for just a few more questions. John, another question for Mike.
Yeah, this is kind of an interesting one. Maybe just in general, you can comment on, Mike, and that is for those of us who aren't that familiar with the kind of operational side of these things, and particularly when maintenance. How do you manage doing maintenance while you're also transmitting 50 kW at the same time going up a tower? I don't think I would sign up for that. So what do you guys do?
So you don't. You according to OSHA and FCC rules, you cannot climb a hot tower. Used to be done very regularly. You put a wooden ladder across the base and go on up, but you cannot climb a hot tower now. So like I said, this station's fortunate enough to have a full-size quarter wave auxiliary tower on their property, and so that's what they do, is run off of that, and that allows them to do maintenance on this tower. So a lot of AM stations, if you have an AM directional with multiple towers, a lot of times they'll have a non-directional mode, so you can just operate on one tower while you're doing maintenance on the others. So.
Okay. And maybe related to that, Mike, is how often does that kind of an event happen? Is this a monthly thing, every 6 months, or what's the general period of performance there?
I would say maybe a yearly thing. You used to have to replace light bulbs probably once a year, every couple of years. You really should have somebody probably climb it once a year and inspect it. So paint it once every, I don't know, 7 to 10 years. Tim, does that sound about right? What do you?
Yeah, I mean, that really varies by location.
Yeah, true.
What the weather does to it. And of course, they're always, as you know, Mike, they're taking a look at that FAA paint chart.
Exactly.
And seeing the amount of fading. So
paint fades, yep.
Yep. So Scott, final question for Mike.
All right. I was curious what the base insulator and the other insulating material that's on the tower, how physically big are they? It's a little hard to tell in the pictures, but how big are those, and what are they made out of? What is the material?
They are porcelain. I couldn't tell you who actually made those, but there's not a lot of companies out there making tower insulators. In fact, maybe one, and I'm blanking on the name right now.
Yeah, and I believe it's up in
Canada,
Ontario.
Yeah.
So, Mike, thanks very much for this presentation and for taking all of the questions today. Just super, and we wish you continued success with your work, and you will always be in the history books of KDKA. And,
about that.
That's a tremendous thing on its own.
I was lucky enough to get to tag along. That was.
Yeah, and getting the ability to work with Bix and all the history that went on there, that's very cool.